So here we're going to look at loans. I highlighted the learning objectives and then reasons for the loans, and I'd like to read through that. And then the amortization, which is a word that I had to learn myself. So just like it says, it's the process used to calculate how much each payment will be applied to the principal and how much is applied to the interest. And I pointed out that I had to learn that myself, as remember the disclaimer that I posted: do not take any financial advice from me. I know the math, but I do not know the finances. So I can calculate, but I cannot give advice. All right, I'm going to go down here. Calculating the loan payment. So here, this is the formula for the interest, which is basically the payment times the rate, which is the percentage, divided by the number of times that you pay in a year. So, for example, I might have this loan amount, $100,000, interest rate 5%, which I have to write as a decimal, and then 12 months per year. So I'm going to push this one over here, somehow out of the way, because maybe, I don't know. Put the calculator here. So basically this is all it is. I take the $100,000, multiply by the interest rate, so 0.05, divide by 12 months in a year. And that means that as I start paying this off, I would have to apply $416 just for the interest. So my first month will be $416. Then, of course, it compounds. But then again, I'm also paying off, and I'm paying off more than the interest. So actually, my balance is going to go down, and my interest is going to go down. And the amount that I pay off from the interest, for the principal, is going to go up with time. All right. And I hope I said that correctly. So let's see. After that is actually, I'm trying to scroll down here. There it is the loan payment formula. And I'm serious when I say here, as simple as it can be. So to a mathematician, math teacher like myself, this one is actually relatively simple. And I try to explain that a little bit later, why I think that is, even though it may look complicated to you. Okay, let's make an example here for this kind of calculation. How much of a payment per month using this kind of formula? And by the way, you do see the compound interest equation inside here. In fact, you see it twice, once here, once there. By the way, they do not divide out because of that -1. So let's see, we're going to look at these data that I already have shared. So here we have a loan amount of $100,000, interest rate 5%, which would have to be used as a decimal. And notice that, maybe you can see that I kind of made that really faint. There's the decimal here, so it doesn't stand out, but it's still there. And then over time of, let's say, 15 years. And again, you might see the 12 here. And then here is the payment formula that I copied straight from the book into this Google Sheet here. And then we have calculate the monthly payment, and if you carefully look at this equation here, that's actually what it is. Okay, here comes the example calculation. All right, I started with some pretty good handwriting. Let's see if I can maintain that. So payment then equals the loan amount times the interest rate, already written as a decimal, divide by the number of payments per year, so for example monthly, 12 here, times, now here comes that formula that we're familiar with from the compound interest, so 1 plus, again, it's the same fraction here. Interest rate as a decimal, so 5% is 0.05 then, divided by 12 months in a year. And then multiply again to the 12 months times the number of years. Notice that this is a huge exponent there, 180, 12 times 15. Notice also my fraction bar is a little bit long. Oh well. Write down actually the same compound interest formula here. 12 to the 15, 12 times 15, there we go. Minus 1, as I said. The fraction bar was a little long. Okay, and plug that into the calculator. Apparently last time I used it was for combinations and permutations. So here we go. I'm going to start a big parentheses here. This will be for the numerator. Again, times this one here. Should perhaps abbreviate that. Here's that little parentheses in the numerator. And here's the exponent, which I'm also going to put in a parentheses. Of course, I could have written already 180. Now I'm closing the parentheses for the entire numerator. This now is my division here. So the fraction divide by the denominator, which I open the big parentheses now. Little parentheses, again, the compound interest formula. And again, the exponent. And close the parentheses for the exponent. Minus the 1, and then close the parentheses for the denominator. So quite a thing here. Cross my fingers that the calculator actually can handle and that I didn't make a mistake. And here we go. And that's what the monthly payment is, $790.79. So, as you recall, the calculator gave us $790.79, and there it is. All right, going down a little further here. There we go. Turns out, actually, they tell us this in the book, that the Google Sheets actually have this kind of formula. I know this one, the original one, looks a little complicated. I still claim it's not. And then it turns out Google Sheet actually has it even saved inside. So here's what I'm going to do. I'm going to click over here. I'm going to copy this exactly the way it says here. So equals negative PMT. And I did that early and it worked just nicely. It actually opened up parentheses for me. All right. Okay, there it is, the parentheses. Then the rate here, well, that would be the 5%, respectively, that 0.05 here. So I'm just going to tell Google Sheets to use E3. And it kind of highlights it. Oh, this is where it comes from, right? And then I divide by 12, but I also have this kind of like almost hidden here. So it's still there, so I'm going to divide by E4. By the way, Google Sheets, and there it also highlights this one here. I'm going to make a comma here for now. So you see here. So this one here, by the way, if you leave it like that and you were to shift this one here, it would actually go to the next tabs. So if you somehow push that formula to the side or down, it would, for example, take an F3 divided by F4. In order to avoid that, you put a $ here. It has nothing to do with the dollar, by the way. In this case, it's not currency. It just means that it's fixed. So if you took that formula somewhere else, if you shift it around, it still grabs it exactly from E3 and E4. So anyway, let's see. I have the E4 here, so I need to do that again. So E4 times the time, so that's 15 years in this example here, so that's the cell C4. And notice it highlights it again, comma, and then the total payment, that's the cell C2. Again, $ here. There we go, C2, parentheses, hit enter, and lo and behold, true enough, the Google Sheet actually has that kind of payment formula in here, which is the same as this, one here, which I have copied here. I wanted to show though that this one here applies nicely, so I'm going to take this one out and just leave this one in here, but the other one is the shortcut. All right. And that then gets me to the amortization tables that we're going to look at in a moment. All right, so let's see what these amortization tables are doing. They are there in order to show that at some point in the future, the loan is going to be reduced to zero and you have paid it off. So this is from the book here, and notice there's actually no zero here. So I will show you in a moment. There is a number here, so I want to look at, let's see which one is that I want to look at. This one here. Just when I just choose this here by random. Again, it also doesn't have actually a zero in it. I'll show you that in a moment. So here $145,000, 750, and so on. And here I'm gonna take my Google Sheet and I'm gonna type that in here. So $145,750, 5.41%. If you carefully look over here, you can see it hidden as a decimal. The term here is 20 years. There we go. And here you can still see hidden 12 months in a year. Notice that the monthly payment calculated with the loan payment formula is $995.20, just like it shows here. Notice that the first row here is identical, and I know this could be shifted off a little bit, right? So here, for example, you see the $145,411.89. Same thing here, $145,411.89. Or, for example, after the 131st month, which is 10 years, or in the 11th year, $85,552.69. So on my Google Sheet, when I scroll down here, I have to find month 131. There it is. And there you see the number again, $85,552.69, just like it says here, $85,552.69. Okay, now let me show you the zero. So I'm going to scroll down here. It says 20 years. Notice here, end of year 12, 13, 14, 15, 16, 17, 18, 19. Okay, getting close. Oops, that should actually read. Sorry about that. End of year 20. I don't do these manually. And there's the zero. So after 20 years, which would be 240 months, the entire loan is paid off. In this case, by the way, on my Google Sheet here, ignore the rest after that. I wrote my Google Sheet for more years and months than just those 20 years. So in this case here, we've actually stopped at the zero here. As I wrote this Google Sheet here, it actually wasn't very tough to do. I'll show you in just a moment. But let me show you any kind of online calculator. I'm sure there's a ton around them. So on the internet. So here is one, calculator.net payment calculator. If I click on home and click on payment calculator, by the way, others are kind of similar here. Interest loan calculator, interest rate calculator, they're kind of similar. Loan calculator, I think that's not that much different. Anyway, I noticed that the payment calculator works pretty well. So I'm going to use the same numbers. What was it again? 145,000. Oh, 750 right there. Apparently I've done this before. 20 years. There we go. And I bet I had done the 5.41% already. There we go. And calculate. And yes, that's the same one, $994.20. When I click on the monthly schedule. And here it's going to go on for 240 months. And of course, this was written by a professional, so they certainly stop at year 20 here, $0, and the loan was paid off. All right, so notice this little diagram here. I'll also show you that in a moment, which doesn't appear in the book, but it does appear on the Google Sheet that I have here. So let me go over this. Here, I pretty much copied all of this one here and put it into my own Google Sheet. I copied it from the book, and then I put that particular graph in there that you saw from the calculator.net. So in this amortization table, which is there to show you, well, this is how much the principal is going to go down, this is how much you're paying off from the interest, and so on. So here what they have is the monthly payment. So that is from the payment formula, loan payment formula, that what is perhaps complicated to me. It's actually relatively simple, surprisingly simple. So that's $995.20. Notice that payment stays the same all the way through for those 240 months. Then the principal here, this is how much is paid off from the principal. There is no big jump here, by the way, because I left out 130 months here in between. So you're paying off more and more from the principal, and you're paying off less and less for the interest because you're able to reduce the balance overall. And then this one here is what accumulates to the total interest. Of course, you wish that you had no interest, but hey, it's a loan. The bank is going to charge you interest. So yes, you have to pay that on top of the original principal. And then the balance is going to go down. Again, because it looks like a jump here. That's why my Google Sheet, or the other one, the payment calculator here, looks a little better because I don't have that jump. So again, the payment here, this is always the same number as the calculated 995, or what I had earlier in this one here that I erased earlier. That was the same one. And then from the principal, notice that as the balance is going down, I pay more and more off from the principal. Okay. I pay less and less interest, still quite a bit. Initially, I pay a lot of the interest and little of the principal, or like a ratio like 2 to 1 in this case, kind of like this one. This is the total interest, how it accumulates. So when you're all done, you have quite a bit of interest paid off. And so when I scroll all the way down here again to that year 20, so here, this is the total interest. At the very end, you're only paying $4 on the last month for the interest. There's that 0 here. And again, ignore all the rest down here. This is the important stuff, the last line here. And so this is the last piece of principal. Notice the balance here, $990.73 being paid off. So that's how an amortization table looks like. And you can monitor that. By the way, again, this hidden one here is the total payment that is not in the book, but it's on the payment calculator somewhere here, at least. It's the total payment, this one here, this line here. So I put that there in order to copy this entire graph here. So you see these 3 lines. So I needed that hidden one as well. So when I go all the way up, this is the same graph that you find on that calculator.net. So this one is the principal that you start out with. And I have to fix something, I believe. I just noticed what I have to fix. I was going to say, my balance is going to go down to 0. No, it doesn't. It stops at $50,000. Well, that's because my Google Sheet isn't perfect. If I put that 15 years in between, by the way, see that here? There it goes down to 0. But I chose this example where I have 20 years, and therefore I have to adjust this one. I just figured out how to do that. I clicked on this graph here, go over here, I think it's edit chart, and then you see where it says G190, that's what I have to fix. So I'm going to go all the way down here and see which one that is. The last line that I need here is, I believe, line 250. So there we go. I know it's 240 months, but the Google Sheet here has its own numbering system on the side, so it's 250 that I have to fix. There we go. Got a chart. Hope I'm doing this right. And yep, there we did it. Okay, so it starts at 145,000, the balance, and then it goes down to 0 when we're done. Not after year 1. Let me cover that. There we go. But after year 20, or 240 months, this one here is the total interest that is being paid over these years. And if you add this last number here to this first number here, you get the yellow line, or as you add the red and the blue all the time, you get the total payment, $238,000. But as you took out the loan of $145,000, you didn't have the money. So, I mean, you wish you had, but that's what loans are about. You might not have the money, so you have to see that I have to pay interest over time. Of course, it's also compound interest, so to say. All right, so let me look at this Google Sheet here a little bit more. These are just numbers here. You can see them here again. Looking, yeah, you can see them here again being typed as I type them in, and then this one here is just this one divided by 100, and so on. And this is all that what the Google Sheet is doing. I have this $995 here that is then simply being subtracted from the balance here with the interest. So see this parentheses right here? That's actually the interest here per month, and then you subtract the payment from that. Then the principal here is, well, subtract these two numbers on top of each other. So for example here, and that's what you paid off from the interest, and then from the principal, and then the interest is simply these two numbers here subtracted from each other. And then the total interest is these numbers here accumulate, so keep adding, for example, the new interest here to the total interest from the previous month, and so on. And then the total down here is, well, keep adding the $995, keep adding and adding it, and so on, and that's the total that you pay off. So writing this Google Sheet actually isn't all that complicated. And as I said, of course, these are also online available on this calculator.net, for example, respectively. I'm sure there's a ton of others out there that do the same thing. Here they actually have this other graph here as well, where they show you, okay, when you're all done, this is actually the principal that is being paid, oh, the other way around. This is the principal that is being paid, the 61% and 39% here. You can see the graph here, $145,000 to 61%. And then I think it was $98,000, that's at 39% of the total, $93,000. There it is. All right. Okay. Lastly, I'm going to go back to the loan payment formula. So this one here, this one has to come from somewhere, and this is what a mathematician would have to do. So I found a derivation of the monthly payment formula. This one here is the definitions, like monthly payment, the initial loan size, so that would be the $100,000, $145,000, and here the 5.41%, that kind of thing. Monthly payment, that's actually what they're looking for. This is actually why that formula ought to be derived, and to me it's still surprising that it's a relatively simple formula. So as he goes through the motions here, he says, all right, for the first payment, the amount you're going to reduce principal is, well, your monthly payment minus the interest rate times the principal, and that's what you then subtract from the original principal, so your balance after the first month is P1 over here. And then you keep doing that, and that's what mathematicians do with the n and the n plus 1, so a month later, and so on, or P1, 2, 3, first, second, third month. And you would actually have to do this 240 times for this particular example. And so this becomes relatively complicated. And here's the m. You have to solve for the m. And how do you take that out of the formula? How do you extract it? That's the word I was looking for. Well, mathematicians have their mathematical tricks. Not a trick. It's still straightforward math. It's what's called a geometric series. It just so turns out, you can see this one here to the first power, to the second power. The next one would be to the third power. There it is, for example, to the fourth, to the fifth power, because it compounds. So that would be the compound interest on that one. And that, with the geometric series, it says here, you can look it up in the Khan Academy or in any kind of good math book, that it comes out to this relatively simple formula, and it ends up then as this one, respectively. This one here with algebra, that formula is this, and this one really is, you see here the compound formula, and here you see it again minus the 1, and here you see the principal, and that one is the same as this one right here, respectively the one that I showed earlier when I wrote it down in handwriting. So that's where that monthly payment comes from, and to me it's still surprising that it's a relatively simple format. And now I'm done with my lecture on loans.